One way to tell that this is an equation that you need to solve without even reading the word solve is that you have an equal sign. Another indicator is that you only have one variable, in this case x. If you have an equal sign and x is and y's, or maybe the y is f of x, you might need to maybe graph those two variables, represent two axes, x and y, and it might mean you're going to two-dimensionally represent what's there, which is a graph. Here we only have one variable and an equal sign, so that is a big clue or big indicator that you need to solve. This way, if you see something like this on an SAT or in another class or in a bigger, more complicated word problem, you kind of know that you need to solve, right? Now, I hope that everyone can recognize by looking at this that this is a polynomial equation, and we have a few things that we need to do right away when we're solving a polynomial equation. I think most of you can anticipate questions that I'm going to ask. By all means, type in the chat as we go or yell out loud, whatever. I'm going to ask you, what do we need to do first? And then what do we need to do next? So if you know what we need to do first for something like this, go ahead and type it in the chat. And even if someone else already did and you were mid-typing, keep going. This way I know you're not asleep, okay? But I see a couple good answers right there. Now, the problem when I walked around the room, when you guys were doing a problem, this problem particularly, or one of the two before this one, is even though you might know that you need to get rid of the stuff on one side, bring it to the other so that one side of your equation is 0, you could tell me to do that and you could start that whole process. When you don't show your work like I'm doing right now, you don't write it down, you make this very common mistake. I see it over and over again on people's papers where you'll say out loud to me, oh, I need to subtract 81x cubed, or I need to subtract 375. You'll tell me that you need to do that. But then what you write down is different when you don't show your steps. What do you write down? Well, I'm going to try to keep it in order. That one was already there. Instead of writing minus 81x to the third, a lot of you accidentally write plus, as if you just picked it up and put it down. You kind of forget to do that inverse operation. So by showing that step, it's going to help you avoid that mistake. A lot of you should know you make one mistake in the beginning and, the whole problem's messed up. Suddenly something that you were going to factor isn't factorable and you're totally stuck, right? Now that we have it equal to 0, right, and we put it in order, we combine like terms, we didn't have to worry too much about that. It was pretty easy. So I see a couple. Nice. So we always want to factor next. Now your eyeballs need to look at this, right? These are your eyeballs. And your eyes tell your brain what it thinks you should do, right? Most people are going to see 4 terms, 1, 2, 3, 4, and go to one method. But what method do we have to discipline ourselves and try to use first all the time? What method? Yes, I hear it and I read it, GCF. Now, we want to make sure if there is or isn't a GCF. And some people will tell me, and it was really funny in period, I think 7 the other day, one of the girls just raised her hand, very matter-of-factly was like, I know I'm supposed to do GCF first, and I do it. And I think I get the greatest common factor, but then it's not. It's not the greatest. I didn't take the biggest thing out. And then I'm like later in the problem and I realized I'm supposed to take something else out. And another girl was like, same, me too, whatever. So we talked about how back, I promise, in lesson 6, okay? So we're in like 14 over here, right? We made it to 14. In lesson 6, beginning of the year, was how to identify the, and bold underline, greatest common factor, because accidentally we do common factor only a lot of the time. The greatest common factor, if you remember, if anybody remembers, it might have been kind of annoying and tedious to you. You might have thought it was babyish or ridiculous. What did I show you to do as like a guaranteed way to make sure you're getting the greatest common factor out of a bunch of terms? Do you remember what we kind of did to the expressions or to the numbers? Anybody recall that? Sometimes when it's very simple, I feel like you don't think about it so much. Looks like nobody's sharing any thoughts. We basically did a prime factorization, or we made factor trees. And I even used the whole story of the greatest con man actor, like greatest common factor. The guy standing at the gate of the carnival, and he's like ripping off people, and he's like, oh, you want to come into the carnival? The carnival's free, but he's charging people admission using his x-ray vision to know how much money everyone's got in their pockets. So he knows like the 27 has a $3, $3, and $3 bill. He knows 81 has 3, 3, 3, and 3 in their pocket. 125 has 5, 5, 5 in their pocket. 375 has 5, 5, 5, that's 125, and 3. So do they have something in common, all 4 of them? I see some head shaking of no. This one has all 3s and that has all 5s. So absolutely no, not, right? They don't all have something in common. So Kate, I think, was one of the first ones that described what we're going to do grouping wise. So GCF won't work. If you want to make sure, you could just break the numbers down a little bit on the side. We memorized a couple of these numbers, so we should know how they break down pretty quickly. Anyhow, carrying on, she was right. She said grouping. She even, I think it was her, described how we could break it down. Now, because I already have this on the side, it kind of helps. So now you could kind of see what your GCF is out of the first 2 terms. So what really is the GCF out of the first 2 terms? Out loud or in the chat? 27 x to the 3rd. Yep. And if any of you are using an Apple or Mac computer at home, when you're typing in the chat, if you hit on your keyboard, I don't know how to do it on another computer, but if you hit on your keyboard, I feel like I don't know the buttons unless I just do it. Control, Command, Spacebar in the chat. So I'm going to do it myself. What pops up is like a character viewer, so you might see a bunch of emojis or pictographs or math symbols, and there's a little search bar. If you have a really older Mac, you might not be able to do it, but say you type the number 3 in the little search and you look at, for me it's on the right, all the types of 3 on the right. I can see a little exponent 3, a little bitty 3 up high, and I see a little subscript 3 and whatnot. So you can get like things like that. You could get emojis, whatever, and use them in the chat. You could use it if you're using iMessage, whatever, anywhere, and you can insert them in what you're writing. So there's math symbols, square roots, whatever. And one other thing you can do is, Althea wrote it as raised to the 3rd. That's fine. If you also have a Mac, though, you could hit, shoot. I don't know, I have to think. Oh yeah, option V, that would make like say a square root symbol, or option P would make the pi symbol, or option 5 makes the infinity symbol. So those are, you could play around with all that. There's lots of hidden gems in the keyboard. So if you ever wanted that in the chat, just so you know, I just thrown it out there, okay? Anyhow, carrying back on. What about the GCF over here out of these 2? And like I said, we have them kind of broken down right over here for us, so it kind of helps.
125.
Yep. And whatever sign is here obviously goes here. Okay, 125. Anyway, we carry on. 27x to the 3rd. Figure out what's in there. Plus 125. Figure out what's left in there is 0. If we use a little pretzel division, what do we get inside of our parentheses? Remember, I want all of you to participate at least 3 times, beginning, middle, end. We only have 7 minutes left. X minus 3, that sounds good to me. X minus 3, and that should make sense. Look, 3 is left, basically a 1, so that makes good sense. X minus 3. Now I'm going to take that X minus 3 and pull that out front, right? And switching to a better pen, I still have then 27 x to the 3rd plus 125. Now, when you think you've factored it, you ask yourself, can I factor more? So is one of these 2 factors definitely prime? Is one of them perhaps something you could factor more? Anything you want to tell me? You want to tell me how to factor one of them further, what method to use, things to write down? Anyone wants to put anything in the chat that's related to what's going to happen, whatever.
I think x minus 3 is prime.
Yep, x minus 3 is prime. We got a linear inside. I see other stuff inside. I see good, good, and good. Yep. Sum of 2 cubes. So X-ray vision, we ask ourselves, what is it that's being cubed over here? And like I said, if you can anticipate my questions and jump ahead a little bit, most of you can. And if you can, that is so good. I remember in college when I started in my college English class, he would assign us reading assignments, and I don't know, your English teacher probably does some sort of like a reading check for you to see, you know, if you really read and if you understood what you read. My English professor asked such good questions that it actually made me a better reader, because I started to learn what to look for as I read, and I would anticipate his quiz questions while reading and always got a good grade on those quizzes after that. So if you can anticipate what I'm going to ask you, then you really understand the problems, right? So we're going to factor this, if you remember how to factor it. If you want to type anything about factoring it in the chat, show me, display what you understand. So I already set up my little glasses. I have the little video where I talk about take those threes off, put them in your pocket, write down what's inside. And then I use my little trick with this times this. This times this, no sign in the middle, we just write that down. And this times this. And then we spell out SOAP. Still, make sure you're paying attention to where I'm writing SOAP, because some of you are still making weird things happen with that. Do not drop your equal sign in a problem. That was something else I noticed walking around the room. Don't drop that. It has to stay there the whole time, because sometimes you do have stuff on the other side and you don't want to forget about it and accidentally turn it to a 0 or something like that. Now, big thing that I told you guys back when we learned this, but I'm going to say it again. This part, quadratic trinomial, if it were factorable, you would have learned how to factor it when we learned how to factor this. Since I never showed you how to factor it, what do you think it means about this quadratic trinomial? Since I never showed you how to factor this when we learned how to factor this to this and this, what do you think that means about this quadratic trinomial? So it's prime. It's not factorable. Could you solve with this? Yes, we're going to learn a way to solve with that. There's imaginary solutions, blah, blah, blah. But for what we're doing right now, no real solution will come of this ever when it comes from a cube, sum of cubes or difference of cubes. So this is nothing, right? It will give us no real solution. I promise you, you can memorize that for now. So how much do we have to solve? Just these two little babies, right? How do I solve from here? I have it equal to 0. I have it factored. Last steps. We're going to do what? We take the two factors, the insides, and we set each, yes, equal to 0. And if you have to show the work, show the work. Probably most of you should. What you'll do, and I say it in one of the videos, if you watch it, I think maybe it was in number 2, you guys autocorrect all the time, where if you're going to end up having to take the square root of a negative, your brain's like, I'll protect you. Don't worry. I won't make you take the square root of a negative. And your brain like flips the sign and you guys write down the wrong thing, which fixes the problem so you don't take square roots of negatives. So you got to be careful. Don't autocorrect in your head, okay? Like the way your phone autocorrects a text or something, like it writes your friend's name spelled the wrong way or whatever. All right, boom. 2 answers, that's it. It did not say graph. It did not say to just factor. A lot of people are just factoring and stopping. It said solve, and that's what we did, all right? So that's the end of this example, and I'm going to make up a new one. Did anyone remember getting these 2 answers? And then for this part, you could have written no real solution. If you tried the quadratic formula, which would be beautiful, if you tried the quadratic formula, you would get a negative number under the radical. And remember, we try the quadratic formula to solve when we're solving a quadratic equation when we can't factor it. Some people love the quadratic formula. Somebody in 6th or 7th period uses it all the time, and they just say it makes their life easier. They don't want to try to factor something. They would rather just go to that. So remember, a quadratic looks like this: ax squared plus bx plus c equals 0. Alphabetical order, EF, right? So this is a quadratic equation. And to solve it, you have to have the equation first. To solve it, we can use the quadratic formula, it starts with an F, which is x equals, do we know it? You should have it memorized from Algebra 1. Negative b plus minus the square root, b squared minus 4ac, all over 2a.
So I did it, and I got the answers, but like, I did it differently because I didn't put the like, I don't know, like, when I subtracted the 81x to the third and
Uh-huh.
stuff,
You put them in a different order, maybe?
yeah,
So when you did grouping, it started off looking different, but you finished the same kind of.
yeah,
That's fine. That happens. So when we even do like AC method and grouping, and we get those two middle terms to split,
yeah,
sometimes people put them in a different order. And when you factor, it still will work itself out automatically at the end. So you might have gotten, like, you took an x out maybe, and then you had 27x cubed plus 125 inside, and then you took a minus 3 out, and then you had 27x cubed plus 125. Is that kind of what yours look like?
yeah,
Yeah. So it's literally like the way we could say, for example, 2 times 3 or 3 times 2. It really is just like that type of a concept. Totally fine. Sometimes I tend to always, just so I do it the same way every time for you guys, I just make sure I always put it in descending exponential order. If you don't put it in like some decent order, like if you maybe flip-flopped it a little differently, it might have been harder. You might not have seen your GCF the same way, and you might have felt stuck. So when in doubt, as long as you found a GCF and you guys work, you're good. But say you get stuck and you're like, wait, what? I don't see a GCF at all. Just try to put them in order if that happens. But the way you did it, nothing's wrong with that.
okay,
All right. I will post a new example of this in the other classes today. I will work out the 2 graph questions from the back, and any ones that you choose to watch and redo before we go back to school is great. Okay. If you get them over with today and not worry about them, that's also great.